All right, good afternoon or morning or whatever it happens to be where you're at. Let's take a look really quickly at exercise 3-4. I've had some questions about it, and part of it is from a conceptual model of what exactly are we looking at on this. So we need to take a look and see what we're actually asking. And so sometimes this is the hard part. It's like those word problems way back in grade school where you had to figure out what exactly you need to do. So let's go down here. So I like to just jot things down kind of in a notepad, just so I kind of know what I'm looking at. And sometimes I can separate these items out and make it a little easier to see what it is we're looking at. So we need a program that lets the user enter the initial height, the bounciness index, and the number of times the ball is allowed to continue bouncing. So my ball, if I drop it from 100 feet and I have a bounciness index of 0.5, it's going to fall 100 feet. It's going to bounce back up 50 feet and then come back down 50 feet. So we've got a few pieces in there. We need to figure out how we're going to calculate those. So let's take a look and see what variables, and maybe that's the place to start, is we'll take a look at the variables and we'll see if things start to make sense. All right, so I know I'm probably going to have one called height, because that's what your initial height from the drop. So I'm just going to say height, initial drop height. And I know that I'm going to have to get this bounciness number, and I'm just going to call it bouncy, because I don't want to have to type out bounciness. And so our final distance, then, is how far that ball travels. So we need to calculate that. So those items we're going to get in some kind of an input statement, a couple of them. Our distance originally we know is going to be 0, so we know we also need to get one more. We need to know bounces. In other words, how many times is the ball allowed to bounce? So what we might do is we could do a while loop and we could subtract them through. We could do a for loop. A for loop might be the easiest way to do this. So, and this is not actual code. We'll go take a look at that now. But so I want to create a for loop, and that's going to range from. So we're going to do a range. And what I can simply do is then input how many bounces we're going to allow that. So we need to create a variable in here, our sentinel value. So we've already used bouncy, we've already used bounces. So maybe we use each pass. For pass in range of bounces. Okay. And so in that loop then, so this is going to execute for every time that we allow that ball to bounce. We need to figure out what that distance is. So at the first stage, before we begin, that distance then, what is that going to be equal to? So we need to set it equal to 0 up here, right? And then for each pass, each time we loop around in here, we need to add to it. So distance equals distance, look at my spelling, plus our height value. And remember, each time that height value is going to go down, but we want the first case. So then we have to change our height. So we say height equals height. And we're going to take it times that percentage that it decreases every time. So if we started at 100, we had a bounciness of 50, then we know that it would go down to 50 feet, it goes back up, and then so each time it would decrease by half. So height times, we're going to call it that bouncy, U-N-C-Y. All right. And we need to do one more thing, which is kind of interesting. So if I think about this, each time that ball goes up and down, it's actually got, we actually need to get both sides of it when it's going back up and when it's coming back down. The first time, we know it's going to drop 100 feet, or 100 units, whatever. So here we've added our 100. It's going to bounce back up 50, and so we catch that 50 as it comes back up. So now we also need to add another distance equals distance plus height. And that's our loop. And then at the end, we can make a print statement that says print total distance traveled. So that's kind of how I write that out. Normally I'm going to sketch this out on paper, but it's hard for you to see what I'm writing on paper. So this is kind of my initial thoughts on, hey, can I put a program together that will do that? So I'm actually going to do it in idle. So I'm not going to put it into our program to test. But one of the things you have to be careful about in this program, it's a program testing your program. So it's going to try to put some of those pieces back in. And now I lost my idle really quickly. Ooh, holy cow, I've got a lot open. So file new, I need to probably close a bunch of those. All right. So I take my notes, my notepad. I need more stuff open on this. All right, notepad. And I'm going to take this and I'm going to do a little conversion. So the first thing I'm going to do is I'm going to say, exercise 3.4. I believe that's which one that is. And then I'm going to set up variables. And so here I'm going to set up my height and all those other items that I need in there. Oop, I don't want that on top of there. Come back. So I know that I want to use these variables, and I can first get it. So I can use a height equals input, and I'm going to say, please enter the initial height of the ball. All right, and so now I need to get the bounciness index. So now I'm going to say bouncy equals. So notice I'm kind of copying what I have here. We're just doing it as inputs. Input please enter the bouncy as index. So we'll just call it that, just to give it a little more space there. And we know that unless we're adding additional energy, it's not going to go past 1. So I just cut it off, said put it between those two numbers. So chunk. And we need one more. We need that bounces equals input. Please enter the number of bounces allowed. All right, so now we get our information in from the user. Similar types of things we've done. Now we're going to do a for loop for, I think we said pass in range bounces. And notice it indents it for us. So then we're going to say our distance equals distance plus height. And again, you can use the shortcuts. I just don't. It's just whatever reason doesn't resonate in my brain, so I don't necessarily put them in. So then we say our height equals height times bouncy. And then we're going to say distance equals distance plus height again. So remember, the first time it does this, that's our drop, and this is then our bounce back up each time. All right, so that's all of our loop. So then we're going to come down here and we're going to put a print statement. We'll print your ball bounced distance. And you could certainly make it much more attractive. But for now, I just want to see if we can make this work. So let's see what happens when we run it. I have to call it something, so I'm going to call it B. I don't think I've used that vol. And it says, oh, invalid syntax. So I need to go back up here and look, and oh, I took those inputs, but remember those inputs are always strings, so I need to probably convert those. So I'm going to convert them to a float, chunk, chunk, and I'm going to convert this one to a float. And just for good measure, I'm going to convert this one. We know it's really an integer, but so I might even do that. I might just leave it as an integer. All right, now let's see if I've made any other strange typing mistakes. Certainly could happen, trust me. Source is saved. Maybe I can't use pass. So let's set x equal to 0. So it's not a very descriptive variable, but so please enter the initial height. All right, 100. The bounciness, let's do 0.5, and let's let it do 10 bounces. Oh. So in here, I also need to figure out, it says distance is not defined. Well, here we're giving it values, but we're not assigning it a value. So we first have to prime that with equals 0, because we don't want it to go with some junk. So let's try it again, 100 feet. 0.5, and the number of bounces will go 10, and it'll say your ball bounced 299.70703.015. Now we could round that off and do some other things to make it look really pretty. We can also introduce you to the idea of what would happen if you put in the wrong thing. We can start showing you how to build some error traps, but for now, let's assume that our users really do put in the amount we wanted, and that seems to work. So let's try that again. I'm going to put in a different number, so I'm going to say from 10 feet. And the bounciness is 0.3. And we allowed it to bounce 4 times. And it's going to say 18.42 feet. So this is my take on it. Are there other ways to do it? Yes. There are hundreds and hundreds and hundreds of ways to do this. But this is one of those ways to do it. And you could shortcut this down a little bit, but this is my take on 3-4. Thank you.